Okay, would you try that first video, Delta Assumption, to see if you have a chance to use I was supposed to, while you're working, I was supposed to mention that there's a CU engineering thing going on in Mr. McCall's room today. If you aren't in AP Physics, you might not have heard it. If you are, I think he talked about it. Does anybody not know what I'm talking about? Want to hear about that? I believe the idea is kind of getting towards the idea of the derivative, which you guys are way beyond, but it's a physical representation, right? It's kind of cool. So yeah, kind of interesting to see this stuff. If you choose a bad delta, you will soon see it in your proof, unless you later fudge your proof also to compensate for your first mistake. How's it going? There you go, something, little something like that. Okay. The steps, the idea of yesterday, constantly 6 hours, said, do I need that much work? I need that much work. Remember, the idea is you're trying to take the person on a smooth journey and not just transport them to the journey. You're trying to take them on a little ride, okay? A fun, logic-filled ride. Are we cool? Yes.
I'm confused about why the negative 1/3 stays negative and
Which one?
the negative 1/3.
From C to D, or from D to E?
Yeah, from C. Yeah, from like D to E. Why is it still negative?
I need it to be negative in order to make the slope, which is negative. Well, okay, so first of all, you agree that I need negative 1/3, right? You with me?
Yeah.
Okay. I did absolute value because if I don't have absolute value, then I need a negative. And if I need a negative, I need to switch the inequality. And there's all this mess in here, right? So the idea is that you're only going to get a negative if you use an absolute value to make it positive, and you don't have to switch the signs. So really it's a byproduct of those things. The slope has to be negative, and to use negative, I need absolute. Yes?
So you get like the term with the x in it to match the term with the x in it and the function, right?
Yes.
And then the leftover stuff, like the 4/3, that's always going to be equal to the constant minus the...
If it doesn't, then something's wrong.
Okay.
Yeah, absolutely. Yep. Okay, that's a good question. All right then, here, let's do some thinking, and I'm talking a little more high-level thinking. This is great. So typically, I was going to hand out scratch paper, but I want your notes to be complete. Typically, you will have, when you do one of these, you'll have a little scratch paper off to the side that you'll use. Think of it like your outline to your paper that nobody sees. Your final product is what people read, not the outline. This will involve a little maddening two-step process where at some point I will hear at least once in here somebody's going to say, this is so stupid, I just did that and I'm just reversing it. Yeah, you are, but you're only showing half of it. I will explain in a minute. You'll need some scratch paper, and at the end you will look brilliant. Like, wow, how did you know that kind of thing? All right, here's how it goes. This is what we're going to prove. We'll start off with a pretty straightforward one. You're going to prove that the limit as x goes to 3 of x squared is 9. Not find the limit, but prove the limit. I don't care that if you go right there it's 9, because that's not what the limit is. The limit is about the approach. All right? So, the problem by far is the delta. And there's not a quick, hard, fast rule like there is for linear, where you just say delta is this. Every curve is different. So every curve will require a different delta. The problem then is you're going to have to find that delta. Now the proof actually goes from x to f, but the delta is the other way. Here's what I mean. So check this out. I need to find a delta that makes this all happen. Now if f is x squared minus, and the limit is, 9, yeah, less than epsilon, I want to take this back to figure out, all right, x minus 3 must be less than question mark. If I could get this to there, then I'll know my delta, because that is, in fact, delta, how close I need to get x to 3. You with me? That's the goal, is to take that to that. Now, how could you take that towards there? What does this have to do with that? Okay, thank you. That's always looking for a factor, all right? I'm not looking for high-level math here, baby, just algebra. X minus 3, x plus 3. Can you agree that that is true? Now keep in mind, when I say, can you agree that that is true, I don't really care if you think that's true, because this is not my proof. Okay? My proof is over here. That's where you got to be hardcore. This, you'll find that as you get good at this, you're going to skip a lot of steps here, because this is just for your benefit only. All right? For no purposes, I'm going to go very methodical. All right. I want to isolate x minus 3. So I'm going to divide by x plus 3, right? So x minus 3's absolute value is less than epsilon over absolute value of x plus 3. I didn't show splitting it up into two separate absolute values and all that stuff. Didn't need to. All right, now here's where it requires a little bit of a leap, but I don't feel like it's a huge leap. You never make a delta. It feels like at that point you should say, boom, there's my delta. Epsilon over x plus 3. You never make a delta in terms of both epsilon and x. It should be delta as a function of epsilon only, period. All right? So then the x is not okay. That's the idea. Now here's where you make an assumption, which is a fair assumption to make. Given that the limit is x approaching 3, you can assume x is close to 3 for this problem. The whole problem is what happens as x gets close to 3. So let's, in terms of what this x plus 3 is like, let's start with the assumption that it's close to 3. It is very common, in fact, almost universal, but not quite, that you say, let's assume x is within 1 unit of 3. So let's assume x is between 2 and 4. If the whole problem is about getting the limit as x goes to 3, then let's assume we're in that ballpark. You with me? Now, I want to take this and build towards, all right, well, what does x plus 3 have to do? Well, surely x plus 3 would have to be between 5 and 7 if I added 3 to each piece. Yeah? You with me? Okay. It's going to be important as we go that you say, no, I'm not with you if you get lost, because this is a butt kicker. If you get confused, you should say so. All right. this is going to be a rule of inequalities. Pause for a second and note, what if I had 1 is less than 2 is less than 3? I think you'll agree that's true, yes? All right. I want to talk about denominator action here. I want to then take this to the denominator. My question for you then is, if I take reciprocals, what happens to the inequality? If I take reciprocals, 1 over 1, 1 over 2, 1 over 3, they all flip, okay? Now that's the truth about positives, inequalities. Are you with me? Okay. Now then, if I do that, then that would imply that 1/5, you don't have to do this, by the way, off to the side every time. This piece is just for educational benefit, right? 1 over x plus 3, 1 over 7. All right, now then, I'm trying in the end to figure out what is this epsilon over x plus 3 got to be like. So you're actually going to bound that. If I throw in epsilon here because I want it, epsilon is defined as a positive quantity. When you talk about the difference on either side, it's positive. There's absolute value all over the place. Epsilon is positive. So if I add or multiply in epsilons here, it's all hunky-dory. Because it's a positive quantity, I don't have to worry about should I switch the inequality or not. That's mathematically so you're fine. All right then. Now, with practice then, you're going to say, boom. Now I know my delta. You're going to let delta equal one of these. Which one? Okay, well, I'm going to tell you. You're going to let it equal epsilon over 7. And I'll show you why. Because that's what's going to make your proof flow in a minute, all right? Now, your notes then off to the side, again, I'm showing you every little step. It won't always be this long. This is your delta. That's what starts your proof. Just like we did in the previous problem, once you have your delta, you start your proof. We're going to start our proof. Now, the idea is, first of all, you let the reader know this is your delta. Let delta equal epsilon over 7. I'm going to show that the if-then statement that basically is the theorem for a limit can be satisfied. If x minus 3 is less than that delta, then it must follow that f of x minus L is less than epsilon as a consequence. If I get that close to 3, then the y will be that close to epsilon, close to 9. All right, here we go. Now you'll see, this is where you're going to want to have this right off to the side, because you're going to do a little two-step here. X minus 3 must be less than epsilon delta, and our delta is epsilon over 7. All right. Now this is where you look brilliant, okay? Because the reader is not going to read all this stuff. They're going to say, epsilon over 7? What are you getting epsilon over 7? What are you talking about epsilon over 7? And you're going to say, let me show you, my friend. Here's how it goes, okay? If you assume x is within, I forgot what I'm finding limit at, 3? Okay, so if x is within 2 to 4, x close to 3, then we're gradually going to build up the, hey, where my epsilon over 7 is coming from. Okay, so how did I build up to that? Yeah, you started by saying, all right, x plus 3 is less than 5 is less than, or 5 is less than x plus 3, which is less than 7, yeah? Okay. The reciprocal idea holds true. What I didn't over here have any is absolute value. Because I'm proving now it needs to be in there. I need two things. I need the epsilon in there and the absolute value in there. Right. The absolute value has to be in there so that I can be sure I'm not changing the sign as I go. It doesn't matter which you put in first. I guess you could probably put in both, but I'll say this. Let's go here. Do you agree that because x is between 2 and 4, it's positive? And therefore x plus 3 is positive, so the absolute value can be put in, and that's not an issue. Because x plus 3 is positive anyway, I can put that in there, no issue. All right? Epsilon over 5 is greater than epsilon over the absolute value of x plus 3 is greater than epsilon over 7. Now here's where we come back to our main proof. After that, I could say, boom. Oh, I wish I wouldn't have drawn that arrow that way. Therefore, x minus 3 is less than epsilon over 7, which is less than epsilon over the absolute value of x plus 3. Okay. Now, x minus 3 is less than epsilon over 7. That's from my starting step for my proof, right? I showed that that epsilon over 7 actually has to be less than this x-ish stuff. You with me? Now, what do you reckon we're going to do next? Just to get a feel, if one person, even one person, can tell me what to do next, that would be super. Because at this point, I'm feeling like it's, whoa, getting lost. What are you trying to get to? Yeah.
Multiplying each side by absolute value.
Okay, I do want to do that. Before I do that, in order, for clarity's sake, you're absolutely right. That is the next step. Actually, before, you're 2 steps ahead of me. This. Does it do me any good anymore? It's kind of served its purpose at this point, okay? Now, I think you'll agree that if A is less than B, and that's less than C, then A must be less than C. And so I'm going to remove the middle term. Like I said, it served its purpose. Now, as Mr. Babb said, we want to start to relate that x plus 3 in and move it over so we can build towards F. I can multiply both sides by absolute value of x plus 3 without worry because it's positive. So if I do that, x plus 3 times x minus 3 is less than epsilon. By the rules we've talked about, that's the same as the absolute value of x plus 3 times x minus 3 is less than epsilon, which is x squared minus 9 less than epsilon, and therefore the difference between the function and the limit is less than whatever closeness you want. All right. How did that go? All right then, perfect. You are in the same shoes as calculus students for the last 400 years since Cauchy came up with this crazy idea. Cauchy is like he's the secretary of the calculus, okay? He's the janitor of the calculus. Newton, Leibniz, they came up with the big ideas of calculus by far, but to kind of make it not all fall apart, to make it can be proven in any way, this French guy Cauchy, he came up with all this stuff. So if you're going to curse somebody tonight, curse Cauchy, okay? Because he's the one that made you do this. All right, yes? Yep.
So how you chose the epsilon over 7?
Okay, I'm so glad you asked that because I want to talk about that. Had you chosen epsilon over 5, how would it have flowed? If you had gone with epsilon over 5, then here, this would be epsilon over 5. Here, where do you go from there? Okay, x minus 3 is less than epsilon over 5, but that's not necessarily less than epsilon over, I mean, it could be, but it might not be. It's like if I said, hey, 2 numbers are both less than 7. How do they compare? I don't know. Okay, by using epsilon over 5, you're finding 2 things that are less than, and you got to know where to go with that. It's only by using epsilon over 7 that you can say A is less than B is less than C, A is less than C. Okay, I'm so glad you asked that. That's a great question. Yes?
So would you always use the smallest limit?
No, that's also a great question. Yeah, what? I thought somebody said, oh, dang it. If there's a fraction and a denominator kind of thing, then it's reversed. And so that's why this is, I got you, because every one is different. That's why I enjoy it. Okay. Yep. Hit me.
Okay, so I'm not sure so the epsilon over 7 was. Like if you're just going at the end, you just go to epsilon and...
Because your delta can't be a function of both. I couldn't use let delta equal epsilon over x plus 3. Delta has to be a function of epsilon only. And so I can't use this as my delta, although it would make my life a lot easier. It's supposed to be.
Doesn't it turn into?
It does. Through a little bit of substitution, eventually, yes, it's less than epsilon over 7, and so yes, but I can't just use that.
So why are you allowed to throw in the epsilon over x plus 3 down there, but you're not allowed to throw it up there? Like after the epsilon over 7?
This is the justification for why I can go here. I can't go straight from, if I understand you right,
Yeah.
I need to explain why epsilon of 7. I can't just go straight from here to here. Nobody would know what that's talking about. This has to be there, or else you're going to, epsilon of 7 got no way. Hey! Why do this?
Well, why does it do why?
That's your proof. The problem is I wouldn't have known that without doing this. And so this is to discover the delta. And this is the actual proof. So as far as what I would see on your homework, I would see that. I don't even see this. Pretty much. Like I said, that's the part that drives students mad. You're going forward and backward, and it feels like, what's the point? It's because I only see you go forward. I don't see all this. Okay? All right. Do you feel like you have enough to try with? Okay, there are some people that said yes. So in order for them, I would encourage you, if you feel like you can do it, try it on your own. I'm going to pause about 1 minute and then I'll start. And try not to look at mine if you feel like you can do it. That's great.
Well, let's do your stuff by yourself. Okay. Next guy. One last.
The answer to the problem. No, it's not. I debated whether it was
F minus one.
So first we need to do is make a figure out
Okay?
so we have to assume
You are because
Okay. Wait, why did you just factor it? Why? Sorry, going so well. Because we need to get to.
let's. Right. Are you getting a little -1 kind of brain? Anybody know what I'm talking about? Oh, sorry. This is what you. Never mind. Ignore me. You're doing great. You just switch things. You're not trying to figure out this.
How do I know which one is
Okay, so that was when I was in your shoes, the hardest part was how do I know which one to choose? The good thing is you're not going to know way down the line. You can know pretty quickly if your proof is going to hang with the choice. So for example, when you're at this stage, but I guess I should pause here. Do you get to the stage where you're saying epsilon over x plus 3 is framed or enclosed by epsilon over 4 and epsilon over 6? Okay. So then your choice, so the hard part is, or the important part is, in your proof, you can't just kind of mindlessly plow ahead. You have to ask yourself, is that sound? Is that true? And if you chose wrong, you should get an error in logic. basically. That's all I can say is be careful with your proof and make sure does that have to be true? And if that's the case, then you can be sure you're doing it right. If you don't understand where my delta choice is coming from, I'm going to be walking around, let me know. Notice I'm skipping lots of steps over there, that's just for my benefit. However quick you can go on the right, cool for you.
So why does limit of x goes to
Because when you do your proof, it's got to be x minus the value you're approaching. So because you're approaching 2, you've got to get x minus 2. So that's why you're isolating. Okay? Another good question was, why do you work for x minus 2 here? Why not x plus 3? Why are you trying to isolate x minus 2? Because, yeah, the x is approaching 2. That's the proof part of it. You're trying to get x minus 2 follows blah, blah, blah. So that's why you're working on x minus 2 isolated and moving the x plus 3. Why is what? Why is this one? Did I, so,
divided by
oh, yeah, when I went from here to here, I divided x plus 3 over. Yeah, you want to isolate that.
so then it is x plus 3.
Well, you missed
In the
it.
middle.
Whereas c is this number you're approaching. Yes.
So if you
Four
chose the
and
wrong
6.
delta, when did you say you would find that out?
In about the second step of your proof, when you try to say this is less than that. If I,
Oh, will it just be like,
yeah, if I did x is minus 2 is less than, if I chose epsilon over 4, then I couldn't really do much with getting this guy in because I would know that I would basically know two things. X minus 2 is less than epsilon over 4, and epsilon over x plus 3 is less than epsilon over 4, but I don't know how those two relate to each other. They're both less than 3/4, but I don't know which is which, so it doesn't go anything.
I have no idea.
Yes?
So, I got to hear like this step over here, but then I don't understand what it is.
These are
so like, you take one of, I think,
Oh, yeah, I got it.
I think you're trying to use that. You need something like in the middle of these two things.
Where, why?
Like, this one's bigger than this.
I said,
Because it's just in the middle, and if this one's bigger than this one, and this one's bigger than this one. And then you use that. It's like to find the relationship between the two rounds. I think that's fine.
Like it's limit of
okay. Yes?
I'm so sorry, I still
No,
don't
please,
understand
please.
why you choose epsilon over 1.
Because look, see, when you do those two inequalities, it's like.
So imagine here, I'm going to write this one more time. Okay? Imagine in your proof then, say you chose this. Okay, if you chose epsilon over 4, I'll show you why it doesn't work. In your proof, you would be stating that x minus 2 is less than epsilon over 4. That's the first part of the proof. You with me? That, combined with this, right under each other, this says that epsilon over x plus 3 is less than epsilon over 4. Now, my goal is to get these two together, relate these two directly to each other. There's nowhere to go from here. I know this is less than epsilon over 4, and I know this is less than epsilon over 4, but I can't make a comparison between those two because all I know is they're both less than epsilon over 4, but I don't know which one's bigger, so there's nowhere to go from there. However, if you took this, and I know that x minus 2 is less than epsilon over 4, and epsilon or over 6, over 6. You with me? If in my proof I said x minus 2 is less than epsilon over 6, and I know that epsilon over 6 is less than epsilon over x plus 3, well, if this is less than epsilon over 6, and that's less than that, then I could put those two together. Does that make sense?
Oh, I get
Okay, cool.
Okay.
All right then.
Just use the value as. I don't know if there's a rule like that, but once you start shooting.
Whatever you do.
Okay. So this is where, again, it's just like an outline. This is a rough draft. It can be as ugly as you want, and the formal should be nice.
I'll bring you
What am I trying to get? 3? Oh, as you absolutely right. Are you doing okay? It sounds like, for the most part, you are. Okay, boom. Then for a little extra flair, you could put a little therefore or a little. Any Latin people? It's kind of like the math form of spiking your pencil at the end. Quo ed demonstratum, that which was to be demonstrated. Okay, that's how you often end a proof. A little of that is what I was trying to prove. Boom. This one's a little funky, and this one's super funky. Are you ready? Who doesn't like funky, right? Okay, well, never mind. All right. Go ahead and start playing around here, and let's talk about the delta choice when you get there. Okay? So you should be working on your choose delta scratch word. This one's actually not funky, it's easy. Easier. I don't want to make it sound like too.
Why did you go into the performance
Only by virtue of the absolute value. Obviously, the subtraction is not commutative, but the absolute value makes sense. Okay. All right, so what's your delta choice? I'm hearing something. Negative 20. I didn't shoot anything negative 20, that's for sure. 12 epsilon. And first of all, epsilon is always positive. Always.
So what? Who did these three
Is that a math? I'm sorry, I didn't mean to insult anybody. Oh, sure, it would be, yes. That side won't matter, but you're right. Because it's one on either side of 4. You're right, absolutely. So 12 epsilon or 20 epsilon? I believe 12 epsilon will make your proof. Ooh, well, yeah, 12. Okay. All right, well, here we go with our proof. We have our theory. Let's see if it works. First, we identify our delta. Let delta equal 12 epsilon. I need to show that if x minus, I go back and forth between x minus c, just the very general and getting a little specific. That's basically the definition of the limit that I'm trying to satisfy. All proof hinges on satisfying an if-then statement via a theorem or a proof or a definition. All right, so if x minus 4 is less than delta, then it must be less than 12 epsilon. Here's where I maddeningly reverse my work. And again, just remember the payoff is you look brilliant to the person reading it because they don't see that you did all this. So if you assume x is near, then you build up to that 4x you want to get. I suppose at some point you could slap absolute value on it because that's all positive anyway. If it's between 12 and 20, it's most definitely positive. And at some point you get an epsilon. How are we doing, people? Okay. Therefore, we bring this fact back to combine it with this fact. And say, therefore, by that, or those two inequalities. Yes, ma'am?
So like, for last year we always did like number and then we did constant and then variable, but does it matter if we do 4ex or 4x or 4 epsilon x?
Oh, good question. No, it doesn't matter.
Okay.
Okay. Therefore, putting those ideas together, x minus 4 I know is less than 12 epsilon by the previous step, but after that side work, I know 12 epsilon is less than absolute value of 4x less or 4x epsilon. So if I remove that middle term, a is less than b is less than c implies a is less than c. Absolute value of x minus 4 must be less than the absolute value of 4x epsilon. Wait. Oh, wait. All right. Now here's where again we want to be careful not to lose the person because there was all this crazy sign changing and fraction stuff. That's where it's going to be important that you go pretty clearly and slowly. All right. So I'm going to go pretty clearly and slowly. Would somebody following you be lost by that step? I divided both sides by absolute value of 4x. Well, certainly not. What next could I do? What small step could I do to also not lose anybody? Okay, put the fraction all in one side absolute value. Beautiful. Okay, what's another thing I could do without losing? Okay, I could flip the should I flip that first and then? I guess it doesn't matter. That's true. Either way, it wouldn't matter. This is true because, again, absolute value. We know it matters the order of subtraction, but with absolute value, not so much, right? Okay, then what? Split it. 4 over 4x minus x over 4x. And I get 1 over x minus 1 over 4. And that is where I was trying to get. Boom. Qualia demonstrata. Right? Wasn't that fun? So now's the time where you start to say, yeah, I think this is kind of cool. Yes. All right, there you go. I got a 1 or 2 yeses. I didn't really think I'd get any, quite frankly. I thought people say nope. All right. Yep. Yep. Because if I had chosen 20, then I would be at here. I would have, from that step in my proof, I would be here, and I would be trying to combine it with this.
Well, I know.
No.
I think you choose the one that.
How did I phrase that?
The epsilon that you're looking for.
I bet I got it.
Oh, sorry, I'm with you. If I had chosen 20 epsilon, sorry, I'm with you. If I had chosen 20 epsilon, then instead of 12 epsilon, it's 20 epsilon.
Is less than.
All right, so I would be there, and from this, I could say that
One on the 20th.
absolute value of 4x epsilon is less than 20 epsilon also, right?
Yeah.
But afterwards, there's not really any way to get those two together with certain logic. They're just both less than this, but I don't know how they relate to each other. Okay. All right. Try this one. Work towards getting your delta, and you'll see that this one has a bit of a gotcha in the what must x be. You'll see in a minute. First of all, I feel a sense of impending doom, and that I am not certain you know how to factor a cube anymore. Well then. Calculator. Okay, so let's do a workaround. Do you know what the first factor is?
X minus 2.
So how can you not find the rest? Or even better, boom.
Oh, that's how I have to do it.
1, 2, that's a 0, -9. 4, 4, uh-oh. Oh, 8, I was doing 8, sorry. No wonder you said, where's 9 coming from? I got you. My bad. All right, 0, -8, and so boom. So, when you divide out x minus 2, what's left?
X squared plus 2x plus 1.
I'm very disappointed in you. Okay, well then, you can see we had a bit of a issue. What would normally we do there? Go back up. Go about the absolute values, try and fence in what x has to be, build out to x squared plus 2x plus 4, right? Right?
Yes.
Okay, well you're going to have to actually do that in two things and put them together. You know x must be between, or assume x is between 1 and 3, which is then going to need to be taken two ways. First of all, what would x squared have to be between? 1 and 9. Furthermore, what would 2x have to be between? 2 and 6. So what would x squared plus 2x have to be between? 3 and 15. Okay, if x squared must be between 1 and 9, and 2x must be between 2 and 6, then the sum of the two must be between 3 and 15. Yes, miss? I'll get that in a second. That I can add in. Once I get the, yeah, I'll do that next. Yes?
Why can't you just do it in one? Like, 1 is less than x.
Why not just say square this plus add it to itself? Well, I guess you can. That's tending to be too much for my feeble little mind. I think.
Oh, but like you can do it.
If you're, let me try to challenge my feeble little mind. So you're saying square. You're saying the rule is you're trying to square it and add it to itself. So if you square this, add it to itself, it is. Oh no! You're squaring it, adding it to 2 to itself.
Yeah.
That's so much for your mind to keep a track of. Plug this into x squared plus 9. You got me there, I guess. I feel you, okay, all right. I always feel so foolish when I've been laboring so hard all these years. Okay. So x squared, what? X.
Do all of them at once, yeah.
All right, do it all at once, genius. Go ahead. 1 squared plus 2 times 1 plus 4.
7.
1 plus 2.
Yeah, it's.
All right, whatever. 3 plus 2 times 3 plus 4. How come you can do this, but you can't multiply 2-digit numbers together? What the heck? It's 19. Is that good?
Lots of little numbers.
It's ridiculous. Okay, so what do we let our, I don't even know where we're at. What, maybe you can see right now. Again, your goal is to cut down the scratch work. Can you tell what delta is going to be? I'm feeling epsilon over 19. Right, because we still have to reciprocal, switch the inequalities, and epsilon it. So apparently, do not skip that step, superminds. Instead, take the time to do it well. You with me?
Wait, so how do you choose the like delta so fast? I don't get that.
I, in my mind, having chosen wrongly, time after time after time, and seeing my proof fall apart, I just kind of now picture when I put everything in, I need to have that trichotomy step work. I'm just picturing that trichotomy step in my mind. Okay, so if we let delta equal epsilon over 19, I can show if x minus c or x minus 2, whichever you prefer, is less than delta, then it must follow that x. Didn't give myself enough room. F of x minus L must be less than epsilon. Okay. I gotta say, for those like super awesome of you, what I've done would probably make a professor crazy. Here I'm going fairly problem specific, but now I'm going general. That's the type of thing that makes a professor nuts. Which, if you want to, that's kind of fun, but generally you want to not cross them. So either go specific or general, but not both. That's silly. All right, so I did bad math there. I'm going to go plus minus. All right. Okie dokie. I do not have anywhere enough. Oh, I wrote so much. I wish you could do that on your paper. All right. Okay, home stretch. We're almost there. X minus 2 is less than. Remember, the proof part needs to be fairly rigorous so as not to lose people. What's the part people are reading? Epsilon 19. If x, according to genius theory, if x is between 1 and 3, then x squared plus x plus 4, x squared plus 2x plus 4, must be between, it seems like such a deal. 1 plus 3 plus 7, oh, it's right there, yeah, 7 and 19. So epsilon, oh no, switch it. 1 over 7 plus 1 over x squared plus 2x plus 4. It's less than 1 over 19. Epsilon over 7 is less than epsilon over x squared plus 2x plus 4. It's less than epsilon over 14. So trichotomy, x minus 2 is less than epsilon over 19, which is less than epsilon over x squared plus 2x plus 4. At that point, the epsilon over 19 has done its job, and you can remove it. X minus 2 is less than epsilon over. Therefore, x squared plus 2x plus 4. I can already imagine you writing feverishly on the test trying to get this in. Stress me out watching you guys take a test. X cubed minus 8 is less than epsilon. Actually, I should have shown the two coming in together in the same value first. the heck? Is that your spot? Well then, have a nice day. Yes.
I'm getting confused because like I think I'm just trying to memorize this, but what is this like typology? What is salad and bad?
So the first part comes from the first step of the proof. When you do if that proving of things given, you assume the hypothesis, the if, and try and show this. So I'm assuming x minus 2 is less than, and I'm right away putting in my epsilon. Right. So that was the first step. And then the trichotomy is saying that if, oh, you did a switch, that's why you did it.
Oh yeah,
This should be this. That's important because otherwise your proof falls apart. If x minus 2 is less than epsilon over 19, and that's less than this term, then surely x minus 2 is less than epsilon over 19. I'm putting this.
okay, cool.
Okay.
Sweet, thank you.
You're welcome.
We have a question.
Uh-huh.
A theory to propose.
A theory.
Can you always choose
Lesser.
the pointy side? So like if you like reciprocate.
Take the reciprocal.
Yeah,
And then always do the one with the pointy side.
The point goes to your delta.
Yeah.
Yeah.
This is an actual theory. The pointy delta choice. Just kidding. That's not a real thing. I cannot think of a counterexample. Also, on the positive side, I can tell you this is 5 times more complicated for negatives.
5 times more complicated?
Yeah, it's much more complicated.
Do you have to learn that? Cool.
No.
Oh, okay.
You don't actually even do that. Maybe you do that in the English
When
Chicago.
it's greater, so when
choose
you
the less-
reciprocate it, then the one that's greater than the middle thing.
Yeah,
With the pointy
the pointy side.
The one that's gonna
Go to, just follow the pointers until you're delta. Whatever. I'm definitely not using that to teach.
Yeah, thank you.
Have a good day.